Okay, students, hope you're doing well. This is hopefully a short video on inverse functions, specifically how to find the inverse functions. What is the inverse function? If we recall, it's the function that takes away what the original function did. It's like going backwards. And we need to recall that the domain of f of x is the range of the inverse. Likewise, the range of the original is the domain of the inverse. And what's the procedure of finding the inverse function? Well, first of all, the original function f of x must be 1-to-1. Then we need to replace f of x with y. We've interchanged x and y, we solve for y. Last but not least, we replace y with f inverse of x. Okay? So from this point forward, this is what we are going to be doing. I'm going to write the original function f of x. We will find its inverse. We'll find the domain of the original. We'll find the domain of the inverse. Likewise, the range and the range. Of course, once we find the domain of the original, it will be the range of the inverse. Once we find the inverse and its domain, we'll be able to find the range of the original. So step one, given the original function, we will find the inverse. Then we'll find the domain of the original, domain of the inverse, and by default, we will have the range of both functions. So that will be the procedure what I'm trying to do from this point forward. Let's start with the simple function. This is a linear function. The domain is all real numbers. So let's go ahead and find its inverse function. F of x equals 7x minus 1. First step we need to do is to replace, well, it's always 1-to-1. We're going to replace y with f of x. So y equals 7x minus 1. We'll exchange x and y. So my new equation will be x equals 7y minus 1. Here we need to solve for y. How do I isolate the y in this equation? Now we just simply add 1 and divide by 7. X plus 1 equals 7y. Therefore, y equals x plus 1 over 7. Therefore, my inverse function will be x plus 1 over 7. This inverse. Of course, this is a linear function. If you recall, this is the same thing as 1 over 7x plus 1 over 7. It's an invisible one here. So this is the slope, and this is the y-intercept. So the domain of the original one is all real numbers. The domain of the inverse, since it's linear, is also real numbers. Therefore, both ranges are all real numbers. Let's try a cubic function. F of x equals x cubed minus 5. I believe minus 6. Anyway, it doesn't matter. Okay, so how do I find the inverse? Well, f of x will replace y equals x cubed minus 6. We exchange x and y. So now my new equation will be x equals y cubed minus 6. At this point, we need to solve for y. So in the equation, x equals y cubed minus 6. How do I solve for y? Well, we may add 6 and take the cube root. So x plus 6 equals y cubed. Now we take the cube root, both sides of the equation. So y equals the cube root of x plus 6. Therefore, my inverse function, x inverse will be the cube root of x plus 6. Of course, if you recall, the cube function is like that. So the domain is all real numbers. The range all real numbers. We just simply push this guy down 6 units. The graph of the cube function looks like this. oops, this way. Of course, the domain is all real numbers as well as the range of real numbers. It just happened that this one goes 6 units to the left because we are adding. So both domain and range for both functions are all real numbers. What about a rational number? Okay, now rational function. Now it's getting more interesting. The function f of x equals 8 over x plus 1. Okay, so notice that now my x is in the denominator. We must avoid 0 in the denominator, so x cannot be 1 here. So we already know what the domain is going to be. Okay, so let's go ahead and proceed to find the inverse function. Of course, it's a one-to-one function. Y equals 8 x plus 1. Replace, interchange x and y. And we simply solve for y. Okay, so now we need to solve for y in the equation. X equals 8 over y plus 1. How do I solve for y in this one? It's a proportion. However, let's go ahead and multiply by the LCD, which is y plus 1, this over this y. So my new equation will be y plus 1 times x equals 8. Since we are solving for y, we need to isolate this for y. So we need to get rid of the parentheses. This particular example, we can do two things. And we can either divide by x. So let me do it that way first. We can divide by x. So we have y plus 1 x over x equals to 1. So y plus 1 equals 8 over x. And we may add, subtract 1. So y equals 8 over x minus 1. That's my inverse function. If inverse of x will be 8 over x minus 1. So you can always divide by x and add or subtract the number, whatever it is. And you can successfully solve for y. A second option is the following. You may distribute the parentheses, which, by the way, this is my preferred method, just because in some cases, that's the only choice you have. You cannot, you will not be able to divide by x. You must distribute. So might as well, I always distribute regardless of which case I have. So let me go ahead and distribute the x. That'll be xy plus 1 times x, 1x equals 8. Since I'm solving for y, this x can be subtracted, 8 minus x, and now since I'm dividing by y, I'm sorry, solving for y, I may divide by x. So y equals 8 minus x over x. Done. That's my inverse function. So let's recall. My original function is f of x equals 8 over x plus 1, and its inverse function will be 8 over 8 minus x over x. So, of course, you won't be able to see this. Okay, so let's go ahead and find the domain and range of both. So I'm going to erase the top. I'm going a little bit fast. Remember, you can always pause the video. So you can always go back. So you just erase this. So now what is the domain? Of course, I must avoid -1 because -1 plus 1 will be 0. So manifold digit 1 will be all real numbers except -1. The domain of this guy, I need to avoid 0 in the denominator, so it will be all real numbers except 0. Since I know the domain of both, of course, I know the range. The range of the original will be all real numbers except 0. And the range of the inverse will be all real numbers except -1. Domain and range for both. Let's try this one. F of x equals 7 over 5x minus 9. Remember, I need to avoid 0 in the denominator. So when 5x minus 9 equals 0, 5x equals 9, I divide by 5. So x is 9 over 5. So the domain of the original function will be all real numbers except 9 over 5. Okay, so we already have that. So we need to find the domain of the inverse on both ranges. So stay tuned. O same old, y equals 7 over 5x minus 9. Interchange x and y. X equals 7 over 5y minus 9, and we need to solve for y. How do I solve for y? X equals 7. We are experts at this point. We need to multiply by the LCD. 5y minus 9. 5y minus 9. This over this, adios. So now we have 5y minus 9 times x equals 7. Once again, this is a good example that we may divide by x and then we add 9 and we divide by 5. And that's the problem, because then it gets something very ugly. You'll get a complex fraction and then you need to clean it up. So this is one of those cases that if you divide by x, you add 9 and then you divide again by 5. You need to do extra work in order to clean it up because you will get a complex fraction, a fraction made out of fractions. So this is why I prefer to distribute regardless. So before I distribute, let me show you what I mean. If I were to divide by x, you have 5y minus 9 equals 7 over x. Then you add 9, I'm going to be lazy here. Then you divide by 5. So now you have y equals this. And you have to, of course, you need to remember your 1033, your intermediate algebra skills to be able to simplify this complex fraction. So this is why I prefer to distribute from the get-go. So let's go ahead and distribute. I can distribute here. That will be 5xy minus 9x equals 7. Remember, we're solving for y. So now we may add 9x. So 5xy equals 7 plus 9x. And since I'm solving for y, I may divide by 5x. So my inverse function is 7 plus 9x over 5x. Nice. Much cleaner than the other mess. So this is what I said. Let me repeat. I like to repeat myself. I prefer to distribute from the get-go. So don't get traumatized later on. Well, this is my inverse function. This is my original. We already found the domain of the original. What is the domain of the inverse? Well, 5x cannot be 0. Therefore, x cannot be 0. So the domain of the inverse function will be all real numbers except 0. And of course, the range will be this guy, and the range for the inverse will be this other one. I'll leave it up to you to finish it. I believe at this point, you know what is the range for both functions. Let's try this other one. F of x equals x plus 3 over x minus 2. This is going to be fun because we have x in the numerator and the denominator. So you will notice that, of course, the domain will be all real numbers except 2. The domain, all real numbers except 2. Okay, let's go ahead and find the inverse function. Y equals x plus 3, x minus 2, x equals y plus 3, y minus 2. I need to replace y, obviously, in both places. And once again, we need to solve for y. If in doubt, when you have a fraction, always multiply by the LCD. So now we have what? Let me write it down. We have y minus 2 times x equals y plus 3. Notice that I have y on the left, y on the right. If I divide by x, this poor y will be stuck over x. In this one, this case, I have no choice but to distribute. When you have variables on top and bottom, the x top and bottom, you have no choice but to distribute. You don't divide by x in this case, just distribute. xy minus 2x equals y plus 3. At this point, remember we are solving for y. So at this point, we need to do what? We must have all the terms that contain y in one side of equation. Okay, so we need to have all the terms that contain the variable y in one side of the equation and the other stuff on the other side. Of course, I have xy on the left here. I have y on the right. You have two choices. Obviously, you can subtract xy or you can subtract y. Try to avoid the number of negatives. Notice that if I subtract here, then I have to subtract x, I mean the 3, to the left. So if I move the y's to the right-hand side, I have a lot of terms that are negative, which is fine. However, let's try to avoid the negative. So in this case, it would be better to subtract the y. So I have xy minus y equals. So we did minus y, and the lovely negative 2x, perhaps we can add it. So we can add 2x, so we have 3 plus 2x. So let me rewrite what we have done there. xy minus y equals 3 plus 2x. And this is the key. Once you move all the terms that contain the y to one side of the equation, we must factor the variable y. Okay, so those are the two key steps. Once you distribute, okay, the keys will be distribute to rearrange all the terms such that all the terms that contains the y is in one side of the equation, and then you proceed to factor. So let's go ahead and factor the y. If you remember, folks, there's an invisible one here. So if I were to factor out the y, it will be x minus 1 equals 3 plus 2x. And of course, since I'm looking for y, I just simply divide by x minus 1, x minus 1. So y equals 3 plus 2x over x minus 1, which in turn, this is my f inverse of x. Inverse, my original. What is the domain of the inverse function? Notice I need to avoid zeros. It will be all real numbers except 1. All real numbers except 1. What is the range of the original? All real numbers, all real numbers except 1. What's the range of the inverse? All real numbers except 2. And we are done. Now, I forgot to mention, if you were to do this composition, this guy, you should get x. And if you do this guy composition, that, you should always get x. At the end of the video, I'll do the composition, but I don't want to lose track since we are focusing on finding the inverse function. So let me give you another example of finding the inverse when we have the variable at the numerator and denominator. And that will be the last example of finding the inverse. And then I'll do the composition of these two in case you need to see it. This last example will have a lot of algebra steps. However, it's the same procedure, folks. First, let's go ahead and find, by the way, all the functions are one-on-one, one-to-one, I should say. What's the domain of this guy? Remember, when the denominator equals 0, I can subtract -5, so it'll be -5, and divide by 2. So I need to avoid -5/2. So my domain of real numbers except -5/2. Subtract 5, divide by 2. Let's find the inverse. Y equals 3x minus 1, 2x plus 5. To change the variable. Okay, and now we need to solve for y. Okay, let's see if you remember the steps. So the first step, since I'm solving for y, your LCD, your best friend, the LCD. And of course, my LCD will be 2y plus 5. So 2y plus 5 for 2y plus 5, that's bye-bye. So I have 2y plus 5 times x equals 3y minus 1. So the first step, LCD. The second step, distribute. Break this parenthesis. So let's go ahead and distribute. I have 2xy plus 5x equals 3y minus 1. Third step, we need to rearrange so that all the terms that contain y is one side of the equation, and then the rest on the other side. If you notice, folks, here, if I were to move everything to the left-hand side, 3y becomes negative, the 1 is negative, and the 5 will be negative as well. So in this example, I prefer to have my y's on the right-hand side, just to avoid all the negative terms. So let me rearrange so that all my y's are in one side of the equation, and I prefer to have the y's on the right-hand side. So I have 3y minus 2xy equals 5x plus 1. Okay. Now, what is the last step? What do we rearrange? So we have this, all the y's in one side of the equation, so we can factor. So let's recap. I believe in repetition, sorry. When I'm solving for y, multiply by the LCD, step 1. Step 2, distribute. Step 3, rearrange so that the y's are in one side of the equation. And last but not least, step 4 will be factor out the y. If I pull out the y, that will be 3 minus 2x. 3 minus 2x equals, of course, this chunk. And last but not least, of course, I think you get it. We just simply divide by 3 minus 2x, 3 minus 2x. So therefore my y equals 5x plus 1 over 3 minus 2x. Which of course we are done, because once we solve for y, and let's see here, of course, this is my inverse function. Therefore, my inverse function is this lovely function. What is the domain? Of course, my denominator cannot be 0. So when 3 minus 2x equals 0, I can add 2x, divide by 2. So 3 over 2. X cannot be 3/2. So the domain will be all real numbers except 3/2. Of course, the range of the original will be all real numbers except 3/2. The range of the inverse will be all real numbers except -5/2. And we are done. Given the original, we found its inverse and the dominant range for both functions. Fini. Well, as promised, the penultimate example we found, given the f of x function, we found its inverse. Of course, if we do the composition between these two, the answer better be x. So by the way, all these examples we should have verified. I skip that. But if I fog them and golf them, the answer should be x. So let's go ahead and start with f of f inverse of x. Namely, this will be the outside function. This is the inside. So the outside function would be x plus 3 over x minus 2. But instead of x, we are going to plug in this other thing. That's 3 plus 2x over x minus 1, 3 plus 2x over x minus 1. So we ended up, of course, with the complex fraction. And if you recall, how do I simplify a complex fraction? We always multiply by the LCD, which of course my LCD is x minus 1. So we proceed to multiply by x minus 1 everywhere. Give me 1 second, please. Give me just 1 second. Plus 2x over x minus 1. Okay, that's the function, right? It will be input plus 3 over input minus 2. So how do I simplify a complex fraction in this case? We multiply by the LCD, which of course is x minus 1. So we proceed to multiply this term by x minus 1. We proceed to multiply this guy by x minus 1, this guy by x minus 1, and this guy by x minus 1. So let's see what type of damage did we make. X minus 1 over x minus 1, adios. So we end up with 3 plus 2x plus 3 times x minus 1. Which in turn is, well, that's okay. And then here, x minus 1 is minus 1, bye-bye. So it will be 3 plus 2x minus 2 times x minus 1. So we can clean it up. So we have 3 plus 2x, 3 times x, 3x, 3 times minus 1, negative 3, 3 plus 2x, minus 2x, plus 2, minus, plus. Combining like terms, let's see what we have. 3x plus 2x, that would be 5x. 3 minus 3, adios. And then I have 2x minus 2x, bye-bye. 3 plus 2, that would be 5. And 5x over x, that would be, of course, x. So 50% down, 50% to go. 1 down, 1 to go. So now we need to find f inverse of f of x. Hopefully we also get x when we do the composition. Let's go ahead and do f inverse of f of x. Now my f inverse is the outside function, so it's 3 plus 2 times input over input minus 1. 3 plus 2 times input over input minus 1. But our input in this case will be, of course, f of x. So x plus 3 over x minus 2, x plus 3, x minus 2. Once again, we ended up with a complex fraction. So we are x squared. We just simply multiply by the LCD, which is, of course, x minus 2. So let's proceed and multiply this guy by x minus 2, this guy by x minus 2. Oops. This guy by x minus 2, and this guy by x minus 2. So we multiply by x minus 2, all the 4 terms. And let's see what we have. 3 times x minus 2 plus x minus 2, x minus 2 bye-bye, so it will be 2 times x plus 3 over x minus 2, x minus 2 bye-bye, so it will be x plus 3 minus 1. I always like to write the 1. That will be minus 1 times x minus 2. Okay, so much cleaner. Let's go ahead and distribute. 3 times x, 3x. 3 times that, negative 6 plus 2x plus 6. And here I have x plus 3 minus x plus 2. Minus x plus 2. We have 3x plus 2x. That will be 5x. Negative 6 plus 6. Adios. And I have x minus x, that's 0. 3 plus 2, that is 5. Last time we checked, 5x over 5 equals x. Done. So when we did the composition both ways, both ways, the answer was always x. Therefore, indeed, the functions are inverse of one another. Okay. The video is becoming very long, but this was our last example. This was my original. This was the inverse that we got. If we do the composition, the answer would be x. So I will not talk on this one. I will do it in silence. And hopefully we get x for both compositions. So I'll leave it up to you to do it on your own and then compare your notes with my notes. We'll see what happens. Best of luck, folks. Perfect. So if I do the composition F inverse of X, I also get X. Hopefully you were able to get that. It gets very messy, but I believe you can do it. Just a matter of being very careful with the signs. Ready to do the last one? LCD. Okay, I pray this is equals to X, if so we are in trouble. -2 times -1 plus 2. Okay, let's see if the magic happens. 15 plus 2, that's 17x. 5 minus 5 is 0. 6x minus 6x is 0. 15 plus 2, that's 17. And voila, 17 over 17 is 1. So this is equals to x. Done. Okay, so hopefully, folks, this helped. Just to summarize, the goal of this video was to show you how to find the inverse function given a one-to-one original function, and also identifying the domain and the range for both. As a just not as a bonus, but just the it also included 2 examples on how to verify that given 2 functions, indeed, those 2 functions are inverse of one another. How do we prove that 2 functions are inverse of one another? If we do the fog and the GOF, namely if we do the composition of the 2 functions, the answer better be X, both ways. F of G of X, land, and G of F of X. Both compositions should be able to give us X. Thank you.